Happy coding.
Hey there, Kevin here, and welcome to our next video in our series on Intro to Web Dev. This week is going to be a little different. We're towards the end of the semester, so a lot of these weeks are a little different. I get a little, I don't know, experimental at the end of the semester. And this week, instead of talking about a new concept in web development, I want to talk about a pretty big I don't know, idea or thing that's happening in the world. And that is, well, as you can tell from the words on the screen, artificial intelligence. And the reason I want to talk about that in this class is it's hard to separate kind of artificial intelligence and coding right now because of the impact that some of these tools have had. And not to be too grandiose about it, as y'all are students like entering the world of like the industry, whatever industry you are in, um, it's a big series of questions around how these AI tools like ChatGPT and Gemini and all those kinds of tools, how they will affect or have already affected the jobs that you will be getting. So I don't know how this is going to go. We're going to see. And uh, Hopefully it's interesting. So this lecture that I'm about to give, I almost never use slides. I think this is the first slide deck that I've used in this class. This is actually a guest lecture that I gave in a upper level computer science class in the software engineering class. I think it's 420 in the computer science department. I gave that a few weeks ago. And so some of the content is like more geared towards computer science majors, but I'm hoping that a lot of it still makes sense and is interesting and sort of contextual for what we've been looking at. So it's roughly 30 to 40 minutes. I mean, I guess if you're watching the video, you'll be able to see how long it is. Um, but this is what we're going to talk about. I'm going to talk about sort of the history of artificial intelligence, at least briefly, and then I'll get into how it works, and I'll get into some of the effects on, okay, the original thing says big tech, but I'm going to make it a little more general for us, and then I'm going to end with a couple questions that you can be asking yourself. Um, so if you are a human in the world right now, you have very likely heard some of the like sensational headlines around artificial intelligence, and depending on what website you're logged into, it's either like all doom and gloom or this is the best thing that's ever happened to humanity. And the truth is likely somewhere in the middle, but all of these screenshots came from LinkedIn. I just scrolled through LinkedIn a couple weeks ago and just took screenshots of like some of the more ridiculous ads that I was seeing. And you have almost certainly seen some of these as well. Um, and this is like, I don't know, the hype is out there. And there's a lot of talk around this being like a brand new thing and it's changing the world and all that stuff. But I don't know, maybe surprising thing is that a lot of this is actually pretty old. So I won't give you an entire history of computer science. I am tempted to because I think it's super interesting. But for example, you might have heard the word algorithm. So we talk about like social media algorithms or like different algorithms that are used in various computer contexts. But the word algorithm comes from the ninth century. The dude in the upper left corner, I'm not going to be able to pronounce his name. It's roughly Muhammad ibn Musa al-Khwarizmi. Um, he invented the term algorithm. And algorithm is just a step by step process, usually mathematical process, for solving a problem, for accomplishing a goal. And um, the like tablet looking thing is an old tablet that is um, writing out how to solve a math problem using step by step instructions, which is an algorithm. Um, Then throughout history, you get things like the abacus, which is in a way a mechanical calculator. You get like actual mechanical calculators. That's the thing in the upper right. And those are, from I didn't look this up, but like from the 1200s through like even today, you might even see a mechanical calculator if you go to like, I don't know, a weird like, uh, hipster like clothing swap and they have like a mechanical cash register. That is still a mechanical calculator, and that technology is super old. Then in the 1800s, around 1837, you get what's called the analytical engine, and this is in many ways like the first computer. And it was sort of created by this dude Charles Babbage, he's in the lower right, and the first software engineer in a way. The first programmer is a woman named Ada Lovelace. That's the woman in the lower left corner. All of this is like super interesting to read more about, but I'll kind of cut myself off there. My point is that the ideas behind artificial intelligence are actually very, very, very old, like thousands or hundreds of years old. Um, then more recently, we get into what people would sort of consider the dawn of the computational age, and this is roughly around World War II, where you have gigantic computers that take up entire rooms. This is computers that have like really like weird like long names with all capital letters like ENIAC or UNIVAC, things like that. And a lot of these are used for, well, war stuff. So like calculating the projectiles of, if you launch a bomb and where will it land, things like that. Um, or even in like the research done for the atomic bomb, a lot of that was on early computers. And some of the famous folks from this age are Alan Turing. So you might have heard of the Turing test. He created that. There's a movie about his life called The Imitation Game. I recommend watching that. Another guy who is maybe a little less famous but very impactful is John von Neumann. He pioneered sort of the idea that computers can be kind of swappable, in that if you have a computer that can do something, another computer can do the same thing. And so, again, trying to resist the urge to get too deep into it, literally every computer we have today is considered a von Neumann machine, from your cell phone to your, the high-end computers that are running, the fanciest websites. Those are all von Neumann machines that are built using the concepts that were developed back in like the 30s and 40s. Um, and even back then, like from day one, when we had a computer, someone was talking about artificial intelligence and machine learning. So even back in like the 30s and 40s, we were talking about that, and we were building programs basically that played things like checkers and chess, that learned how to play checkers and chess by playing like many games over time and recording moves that like led to wins and led to losses, and then doing the ones that led to wins more often. I'm oversimplifying that, but we think of these as like really modern day technologies, but they have been around since the very early days of computation. Um, One specific example that kind of I don't know, is a bit of a spoiler maybe for modern day like sort of AI, is a program called ELIZA. This was back in 1965, and it was a project that created like the world's first chatbot. And, by modern standards, it probably wasn't all that great, but it was a computer sort of talking to a human back and forth. And folks even started using it as like a therapist, which was kind of a big deal back then. Um, and we started talking about the idea of neural networks way back in like the 40s, 50s, 60s. And I'll come back to that idea, but it's not new. It's at this point almost 100 years old, the idea of a neural network. Um, okay, so I'm kind of fast forwarding, and we go from like the 40s, 50s, 60s, and we go from World War II more to sort of government research and getting into like the applications of what can we do with these computers. And this led to a lot of conversations, a lot of promises around here's a thing that the computer can do. And if you just give us a bunch of money, we will develop that technology. And so a big part of this was like speech understanding. So trying to translate one language to another. This is related to like the Cold War and trying to understand, Russian and stuff. And governments gave these research institutes, mostly like big colleges like Stanford and CMU and that kind of place. Um, Governments gave these research institutes a lot of money with the promise that they would develop these artificial intelligence programs. And long story short, they didn't really deliver. So governments were giving like millions of dollars to these teams, and eventually it kind of just ran out because they didn't really have the results to show for all of that investment. So there's a couple of quotes here that you can kind of read through, but one of the big things that came out was something called the Lighthill Report, which was a sort of a breakdown of all of the research that had been done. And one of the things it found is basically like none of this is real. And so um, this led to funding basically drying up for AI research. And this is referred to as the first AI winter, because if you look at funding over time, it like went up and then kind of crashed. And it's led to people not researching or investing in AI for a while after this. Okay. So then we get, I'm kind of fast forwarding, we get into the 80s, and this is kind of the early 80s, I guess. And at this point, companies start developing what are called expert systems. And these are, for the most part, like rule-based systems. And so you can sort of see the flow chart here. I'm kind of looking at the video. I don't know if that'll show up really well, but you can think of it as a decision tree. So like, should I wear a red shirt or a green shirt today? If I wear a green shirt, what color pants should I wear? If I wear, jeans, what kind of shoes should I wear? If I wear sweatpants, so on and so forth. And this is a way for computers to like make decisions. And in fact, we learned about if statements earlier in this semester, and this is kind of if statements like exploded. This is I don't know, the $1 million version of if statements. And these expert systems were coded with, well, like expert sort of decision making. And so you would do something like interview a doctor and say, "Hey, doctor, how do you diagnose this disease? And what's your flow? Like, what's your decision making? If your hand looks like this, then you have this. If your foot, I don't know. I shouldn't come up with medical examples on the fly." But this was a big industry that was highly invested in and resulted in like custom hardware. And so on the right here, or like right above my face, is an example of an expert system. This is kind of what they looked like. And they would be kind of specialized computers that like sat in a doctor office or sat in like a business sort of making decisions to help a business, whatever it was. And they would be an expert, hence the label expert system. Um, and the challenge with expert systems is that they are really hard to maintain. They're really hard to update. And basically, if you have like a new rule to add, you have to like figure out where in the decision tree to add it. And you have to go and like update your specialized hardware to make that change. And it's just kind of hard to maintain, expensive to maintain in the case of, folks who care about that kind of stuff. And the other thing that was happening sort of simultaneously was the market for specialized hardware was dwindling because we were getting like the PC, the personal computer, which was a more generalized piece of hardware that could sort of do a little bit of everything instead of just being a really specialized piece of hardware that sat on the third floor of your doctor's office or whatever. Now there was a PC in every office. Maybe not quite every office at this point, but it was getting to that point where if you were going to buy a computer, why would you buy an expert system versus getting the thing that could do a little bit of everything? So this led to what is called the second AI winter. This is in like roughly the 1990s. And again, it was this pattern of a lot of investment going into these expert systems, and then the demand for that kind of drying up, and then a lot of companies going bankrupt and closing and stuff. The other idea that sort of comes up during this time frame is that quote at the bottom, which is the argument that AI didn't really go away. We just started calling it a different thing when it was more mainstream. And so there are things that like your PC does that are technically AI, but we just don't think of them that way because they're just kind of everyday things. Like, for example, spell check, that is AI, but we don't call it that really because it's just spell check, right? But the research that had to go into that at one point that was considered AI. Um, so anyway, this is roughly the 1990s, and we've got like our second AI winter here. So I'm going to take a short detour and talk about the dot-com bubble burst. And this is not really technically part of AI, but I think it's an interesting sort of, I don't know, historical event to reflect on and ask ourselves questions about it. And so in the late 90s, the internet was becoming a thing. More people were getting like home computers and more people were connecting to the internet. This is the era of like, I don't know, AOL CDs being sent out to everybody. And what happened was um, venture capitalists, who are like people who make a living investing in companies and then getting profit back from those companies, um, they heard, hey, the internet is a new thing. And so any company that had like .com in their name or like internet whatever, it didn't really matter if they were profitable because they had the internet. They were involved in the internet. So of course, eventually it will become popular because look at how many more people are using the internet. And so all of this money flooded to these companies. And a classic example of this is pets.com. So pets.com was basically like Amazon for pet food before Amazon was really a thing. So you could go to pets.com and like order a bag of dog food. That was what pets.com was. And it was an early internet company. And in 1999, in roughly 6 months, they only earned like $619,000 in revenue, but they spent almost $12 million on advertising because they were just getting so much money, and that's what they did. So there's this really famous, like, I don't know, Super Bowl commercial that's kind of ridiculous. And this is just an example of the imbalance between how much money these companies are receiving in investment despite not really making much money. $619,000 might seem like a lot of money, but if you have a whole company to run and people to pay and expenses like dog food's not free, you got to buy the dog food somewhere. It's actually not all that much. And so what happened is that these companies failed to live up to the hype. They failed to generate the money that it would take to pay back their venture capitalists, and so they went out of business. And so that chart on the bottom there is a chart of how much money was being invested in companies. And so you see a huge spike in the late 90s and then a huge fall off, and then it kind of normalizes over time. But that is what we mean when we say like the dot-com bubble. Okay, so I am going to fast forward quite a bit in time, and now we are after the dot-com bubble. This is now in like the late 2000s, early 2010s, and this is where the idea of like big data starts being a thing. And so before we had the internet from the 80s or so, and at this point the internet is like very popular. We now have like iPhones that people are carrying around in their pockets. People are using the internet every day, and we go from the product being the thing you're using to the product being the data you generate. So a classic example is Google search. um, so at the very beginning, Google worked by being a search engine. You could go to Google and you could search for a thing you were looking for, and it would give you results. And to consumers, that's still mostly true, I guess. But around this time, these big companies realized that those searches, the history of those searches, were useful data by themselves. And so this is how you get things like how does Google know when you make a typo? It's because they have billions of searches over decades at this point, and they can tell when your search query is just a couple letters off from a million other search queries. And so they could say like, hey, wait a second, did you actually mean this other thing, because it looks pretty similar? And that's the idea of big data. So we get a lot of labeled data sets, which is um, data that has been sort of annotated, and like labels have been provided. So for example, Amazon reviews was one of these, where Amazon published a bunch of their reviews. And so you could start to get a sense of like, in this data, if we look at all of the 1-star reviews and we look at the words in those 1-star reviews and we compare those words to the words that are in 5-star reviews, you can maybe start to get a sense of what words are more positive or negative computationally. So you can write a program that starts to understand like sentiment, for example. There was another big, I don't know, sort of data set, which was from Netflix. This was called the Netflix Prize, where Netflix published people's like ratings. It was anonymized, but there was a whole big mess over it not really being anonymized. But and they had this challenge where if you could write a computer program or an algorithm that looked at all of that data and then could predict movies or shows or whatever that someone would watch, then they would give you money. And so this becomes like a whole field of study, big data. In fact, in grad school, I took a class on big data, and that is like the early days of like training data that we still talk about today. Around this time, we also have Watson winning Jeopardy, and this is a computer that wins Jeopardy. Uh, and that means that it is like taking questions that are worded just like a human would word them, and then doing, some AI stuff and outputting an answer in the way that a human would. And that was back in 2011. That was a big like AI milestone. Um, and then very importantly, and I think I talk about this in a little more depth. Let me remind myself. Maybe back in 2012, Alex Krzyzewski, who is like very famous now, he releases a new piece of software. So for background, there was this competition basically where participants would be given a bunch of images, and the competition was to label the images. So, what is this a picture of? Is this a cat? Is this a dumpster? Is this like a tree? Is this a cloud? To write a program that does that. And this had been going on for years, and this was like a big AI thing, kind of a niche, like competition for nerds. And in 2012, this dude, Alex Krzyzewski, he creates a program for this competition. He calls it AlexNet, and the remarkable thing about this is that his program was relatively simple. Um, it was a neural network, which I'll talk about in a second, trained on two GPUs. And a GPU is a graphics processor unit, I think that stands for. It's a graphics card. So if you have, I don't know, like an Xbox or PlayStation, they have graphics cards. It's mostly a thing for video games. And if you have like a gaming PC, you would, you would get a graphics card for that. And, it's a thing that you can just buy off the shelf, literally. And before this, the entrants to this competition were trained on CPUs, on computers, and so the training was kind of, I don't know, slow or expensive. And so the big deal here is that this guy realized that the math that was involved for training a neural network actually was pretty similar to the math that is involved in rendering a video game. Um, and so he took the hardware from video games and he threw a neural network at it. And this worked so well that he blew the competition out of the water. His program was like simpler, but because of the hardware that he used, it was so effective that it blew every other competitor out of the water here. And this starts what's considered the deep learning revolution, um, and that's like how we get to today. So this dude is real famous. And around this time we get Word2Vec, which I'll talk about in a minute. Okay, so that kind of brings us to today. So fast forwarding, we're going from like 2013-ish, kind of hitting the fast forward button here. In 2016, we get some pieces of software that are still important. I won't go into too much detail, but we get things like encoder decoder that's developed seek to seek. Google Translate switches over the technology they were using. In 2017 there is a paper published. It's called Attention is All You Need, and it introduces a concept called transformers, which are not like robots in disguise. It's a technology that is used in AI, and this paper was released by a bunch of Google scientists. And the reason this is important is transformers are still very, very important in AI. In fact, ChatGPT, the T in ChatGPT stands for transformer, and it's based on this paper from 2017. So this paper is released, and it's kind of this, I don't know, niche thing that no one except for AI nerds really care about. But in 2022, OpenAI releases a new product called ChatGPT, and it's based on that research, and it is, you know what it is. It's revolutionary in certain ways, controversial in other ways, and has led to a lot of the conversations that we are still having today. Then there's a bunch of other things, multimodal models. This is things like you can type in a request and get an image back. So you're like working in different modalities. You can, talk to the AI and say, generate a video that does this. So you're working in two different modalities instead of just like a traditional chatbot would be you input text and you get text back. That's a relatively recent development. Things like image generation and code generation as well. These are things that are still being explored today. So that's a brief or maybe not so brief history. So next I will talk at a high level, how does it work? How do these things work? This could itself be, well, it's an entire field of study, but I'm going to try to fit it in just like 15 minutes. So I mentioned earlier neural networks, and neural networks sound like a science fiction-y kind of thing. But the actual like foundational idea behind them is relatively straightforward. And so if you think about a neuron in your brain, the way they roughly work is they have an input and an output. And the input takes like electrical signals from other neurons, and then inside the neuron, it takes that input and sort of processes it, and then outputs the processed signal to other neurons. And if you scale that up to billions and billions and billions of neurons, that's how brains work. It's electrical signals sort of propagating through a network of neurons. Um, and that's, very roughly in 30 seconds how the human brain works. That's as best as I'm going to do. Um, and artificial neural networks operate under a very similar sort of concept. And so in the upper left corner, here's a diagram of what you might think of as an artificial neuron. And so X1, X2, X3, those are inputs, those are input signals. And the circle in the middle, that is, I would consider that the neuron. In computer science terms, we often call this a node, or a node in the network. And the math in the middle might look creepy. Like whenever I see a Greek letter, I always get a little freaked out. But really, it's just addition and multiplication. So you have your inputs. We can call them X1, X2, X3. Maybe XYZ would be better, but X1, X2, X3, they're just inputs, they're just numbers. And what the neuron does is for each of those numbers, it multiplies them by some number. So you have W1, W2, W3. These are called weights. And then it adds all of those together. So it's X1 times W1 plus X2 times W2 plus X3 times W3. And then it takes that number and outputs it to the next layer. And I shouldn't say layer, feeds it into the next neuron. And, you can have one neuron that goes to many, you can have many neurons that feed into one. And the end result is this like signal that goes through the network in exactly the same way that the human brain works. Or I shouldn't say exactly, but a rough approximation. And then what you get at the very end is a set of signals, a set of processed signals on the other side. And these are all numbers. At the end of the day, you're inputting numbers and you're outputting numbers. This is a neural network at a high level. Okay, so I mentioned that neural networks deal with numbers, but doesn't AI work with words? So how do you map words to numbers? Um, there's a bunch of ways that you can do it. So you might think of just giving them random numbers. So like, I don't know, spider is 7, squirrel is 73, paper is 9,467. And that would work in giving them numbers, but it wouldn't really help you, because you want words that are related to have similar numbers. And so random numbering, that wouldn't really work. The other way you might do it is alphabetical. So like aardvark is 1, ant is 2, bee is 3, cat is 4. I don't know, there's other numbers in between those, but the idea is that you have a sort order. You have the ability to apply numbers based on a simple algorithm. And that might work, but again, you're not really sorting similar words into similar numbers. So I don't know, think of two words that are close together alphabetically, but very different in meaning. So alphabetical is kind of out. And so what you want to do is give your words numbers that correspond roughly to the similarity between those words. And so one of the ways to do that is with basically fill in the blank. So you look at a bunch of input text. So you can consider maybe sentences. You look at a bunch of sentences, and for each of those sentences, you take a word out and you then look at all of the other sentences and you say, what words complete this sentence? And if you're doing this for like large data sets, so, every Google search or every page on the internet, you're going to get repeats. You're going to get sentences that are very similar, except for one word is different. So, for example, my favorite season is blank. You can imagine if you have searched through enough input data, you will see this probably thousands of times. And you can then come up with a list of here's all of the ways that that sentence has been completed. And so you might get, the obvious ones are like, my favorite season is summer. My favorite season is winter. Maybe some non-obvious ones would be like, my favorite season is football season. My favorite season is, I don't know, wedding season. Uh, and so you might be able to get some meaning from how you fill in those blanks, and that gets us closer. However, there's a challenge there where related words are related to each other in different ways. And so, for example, summer and winter, they are related. You can fill in the same blank there. But summer and hot are also related, um, but in a different way. And winter and cold are related, but is summer and cold related? Maybe not. So maybe those words don't all belong together, but maybe there's other ways that they sort of relate. And so this gets at multidimensionality, which just means that instead of giving every word one number, you give every word a bunch of numbers. And so here's an actual example. Earlier, I mentioned a piece of software called Word2Vec. This is in the early 2010s, I think. And this is a algorithm that takes a bunch of input words and comes up with numbers that sort of correspond to similar words. And so I will say, as a disclaimer, the original paper that kind of published all of this research is a little, I don't know, a little cringe by today's standards, in that it's pretty gendered, and I don't love that. But this is the famous example from it, so I stuck with it, even though it's a little awkward. But anyway, this is the actual number behind the word king, and by themselves, they don't mean anything. This is just the numbers that the algorithm came up with by looking at a bunch of input data and trying to finagle all of the words, all of the numbers, so that similar words are close, sort of numerically, and words that mean very different things are far away in these multiple dimensions. And to show you what I mean, there's a visualization that I really like. So this is a visualization of the vector of the numbers that we just saw. And you can see that each individual number kind of ranges from +2 to -2. And so you convert that into numbers by saying, like, numbers that are close to -2 are blue, numbers that are close to +2 are red, and it just gives you a quick visual of the numbers, which is maybe a little easier to like glance at than this big ugly thing. And so if you take this visualization and you visualize a bunch of words, you can start to notice patterns. And I kind of warned you that it was a little gendered, which is obnoxious, but here is the visualization of the vectorization, which means the numbers of several different words. And if you just kind of take a step back and look for patterns, you might notice that there are, some trends that stick out. So first off, I noticed this this red column. And so all of these were a similar value. I don't remember if it was -2. So that's +2. The red ones are +2. And so in this dimension of the number, these were all a pretty similar number. And by themselves, the numbers don't mean anything. You have to kind of squint and think, um, what could this mean? And just sort of glancing at the numbers or the words, all of them are nouns. And so I can say maybe very roughly this dimension of the vector, this dimension of the numbers, maybe this is encoding some like noun property, like it grouped all the nouns together in that one dimension, maybe. Another thing that pops out is I see this blue here, and it's like bright blue for most of them, but then, kind of light blue for this one down here. And then if I look at the words, I can kind of guess and like maybe the blue, maybe this dimension is encoding like a person. Like water is not a person, so it's a little further away in this dimension. Whereas the rest of them are people. So, we're kind of guessing, but it kind of makes sense. And let's see. So then I noticed that like you've got maybe these two red ones, these dark red ones. And if I look at that, it's woman and girl. So maybe this is, again, gendered, but maybe this is encoding for gender in the training data that it had, which gets at other stuff that I might come back to later. And so maybe, I also see that like woman and man have these in common. So here's a bright red one and a bright red one. And the rest are kind of dim. And so maybe this is encoding for age, maybe like woman and man are older than boy and girl, maybe. Um, I've got let's see, over here in the blue, on the oh, my face is in the way. That's why. Let me turn my face off. Sure. So over here on the right hand side here, I see that king and queen both have this like kind of bright blue. So maybe this is encoding for the idea of royalty, maybe. And again, we're kind of guessing because really the actual values are things like this. If you look at any of those numbers, like why is this 0.33505? Who knows? That's what the computer decided the number should be. But if you look at it in sort of, this zoomed out view, you can kind of start to surmise or start to guess at what some of them could be. So that is the idea of encoding or giving a word a numeric value. And the reason this is important is because this lets you do math with words. And so for this specific example, if you take the numbers for king and you subtract man, the numbers for man, and you add the numbers for woman, you get the numbers for queen. And this is huge. This now means that you can do math with words. And this is for me, this is like moment when I learned about this, because I don't know, it unlocks some questions about how language works that, in our human brains, I don't think we're doing this math, but maybe that's what our neurons are doing. Who knows? And so this becomes a really important idea of I can do math with words, which means I can throw them through a computer program, a neural network, an AI algorithm. Okay, so I won't get too far into this because this gets like pretty far into the like computer science stuff. But in these kinds of tools like ChatGPT, Gemini, you'll often have a couple of different sort of pieces to them. And so you have what's called an encoder, which converts your input to numbers. And then you have a decoder, which converts those numbers to output or like words, in theory. And the numeric representation of that input or output, I'm trying to be vague because it can be words, it can be text, it can also be an image, it can be a video, it can be sound, it can be really anything. But you're converting something to numbers that you can then do math with. So grouping similar things together. Those are called embeddings, the numeric representation of it. And this is what lets you do things like multimodal models where you take something like, I don't know, like I'm talking to my phone. It takes the voice recording, the sound file, and encodes that into an embedding into numbers, and then it does some math with that, and then is fed into an output layer, and so decodes those numbers to output. So, for example, let's say I'm talking to you on my phone. I've got like the Gemini app open, and I say, "Hey Gemini, give me a picture of a cat holding a wizard wand." Um, that file is converted into an embedding. It's numbers, numbers that you can do math with, and the math understand. It doesn't understand. I shouldn't say the word understand. The math recognizes the numbers that represent the idea of a cat, that represent the idea of a wizard staff, that represent the idea of an image, and the output converts those numbers into an image. And that's kind of how it works at a very high level. When you ask like, hey, ChatGPT, give me an image of that, it's converting your input into numbers, converting those numbers into an output, using some of the techniques that we covered above. Okay, so real briefly, I'll touch on this idea. This is the last like technical thing I'll cover. And earlier I mentioned the paper from Google, which was Attention is All You Need. And this introduced a concept called transformers, which is still used in like every major AI tool today. The T in ChatGPT stands for transformer. So what is a transformer? Earlier, I talked about like turning words into numbers, and the challenge with what we were talking about earlier, word2vec, you can do math with individual words. So like king minus man plus woman equals queen. The problem is that you're generally not dealing with one word at a time. You're usually dealing with like a full like paragraph, like many pages of input, like a whole like whatever you would give ChatGPT, all of that is the input, and so you have to do math with the whole thing, not just one number. And so, for example, words mean different things in different contexts. So, fall is my favorite season versus don't fall down the stairs. The word fall, it's actually almost two different words. And how do you math that? How do you convert that into a number? And the answer to that is you take the entire input and you figure out how the words are related to each other. So this is just a really like, I don't know, kind of arbitrary example, but in the sentence, fall is my favorite season, what you do or what the algorithm does is it looks at each word and it asks, how is this word related to the other words in my input? So in this case, in this sentence. So for fall, maybe fall and season are very related. So if I look at the intersection of fall and season, that is, oh yeah, my face is in the way again. Of course it is. I'm just turn it off. So if I look at fall and season, that's, a big number, 90. Versus if I look at like fall and is, maybe fall and is, that's not quite related. Like, this could be like was or will, this could be a bunch of different things, but fall and season, those are very related. Versus like, I don't know, like my and is, not really related. And so what the computer is doing is paying attention to each word and then figuring out how related to every other word is that word. And that is the idea of attention, where you're paying attention to each word. And then the idea of a transformer is just this whole thing. So instead of a series of numbers that represent one word, you have a series of numbers that represents your entire input. And that's what a transformer is. That's a big concept in all of these tools. All right, that's enough of the tech sort of details. And let me look at time. I'll try to hold myself to an hour. We'll see. So that gets us to these tools that exist. So LLMs, or large language models, chatbots, things like ChatGPT, Gemini. What are they? They are by themselves very smart autocomplete. So they are using this underlying technology of a transformer to take input and predict the next word. They take your input, they convert it into an embedding, and then the only math they're doing is what's next. And they ask that question sort of over and over again to give you the output. And so I don't know, the question you might ask is like, wait, but like ChatGPT is not just autocomplete. Like I can ask it a question and it gives me an answer and it's doing interesting things. And that's because these tools are actually like several models. And so you have the large language model. So you have GPT, for example, is a model. And that is just doing autocomplete. And then on top of that, you have a completely separate thing that is using the underlying model, is using GPT, in the case of ChatGPT, to generate responses that feel like chats or feel like, you know, a homework assignment, that feel like, you know, whatever, fill in the blank. And that's based on a whole separate thing of training that tool, that model on good input versus bad input, or good output versus bad output, like what looks like a chat versus what's garbage. And so this is where a lot of the investment comes in, is spending the human time to say, yes, that's good input, no, or yes, that's good output, no, that's bad output, until the like top layer generates the output that you want. Okay, so I won't get super into this. I actually think what I'll do is I'll spin this out into its own talk, but just to give you, I don't know, an example of the kinds of things that you can do with this, and the like reason that it's kind of, I don't know, such a big deal to people right now, is you can do a lot with it. So I'm going to open up a tool called AI Studio. This is a Google product, and I'm only using it because it's what I am the most familiar with. There's a bunch of these types of tools, but this is the one I've seen just because that's where I work. And so what this gives me is a text box that says describe your idea. And so I'm going to paste in this just as my example. So I'm saying build a website designed for Millersville University students that lets them pick where to eat dinner. Use the Gemini API to ask the user what they're in the mood for, and then output a suggestion, make it Marauder themed. So Gemini is basically like Google's ChatGPT, if you are not familiar. And what it's going to do is take my input, create an embedding out of it, and then feed that into a tool, this tool, that will write code for me. So the output of my embedding will be code. It won't be like, you know, a back and forth with chat. It will be code. And so I didn't plan this ahead of time. I don't know how long it's going to take, but right now it just says thinking up here. And in a minute, it's going to start like writing code. And you have, you know, in this class, you know, well, we'll talk about this in the next video. Many of you have been writing your own code in this class, and so you know what it feels like to write code by hand. And this is a different way of doing it. I'm not going to say better or worse, at least I'll try not to, but when it generates what it's going to generate, you can imagine, how long would this have taken you? And maybe I'll turn off my face again just to be able to show the whole thing. But it's something. I've got an input here. What ye be craving, matey? It's a little goofy, but sure. And I don't know, what am I craving? You know what I want? I want some oh, I should have chosen a better word. Rella sticks. How do you spell mozzarella? Sure, that. Uh, and I'll click this, and it's doing something. And you can imagine that you could write JavaScript code that does this. Now, I haven't gone to Millersville in a long time, so I don't know if this is actually a thing. Is this real? I don't know. Maybe. um, but let's look at some of the code that it generated. So that's the website that it generated. But here's the code. It looks like this is in a specific thing called React, I think. But here's an index.html. It's HTML. Here's let's see. Here's some React code. We haven't really learned about React, but here's some HTML you can kind of see. And it works. I could maybe make a change. I'll say like use vanilla JavaScript, and HTML instead of React, just so we can kind of look at it. And this modality of instead of writing all of the code myself, what I'm doing is like talking to a tool. This is a big question in the industry. Is this the future? Is this the future of coding? I don't know the answer to that. I have my own mixed feelings, but this is a big question right now. I'll let this finish and then we'll look and see if it worked. But hopefully this shows like just a real quick preview of the kinds of things that this technology unlocks in the coding world. Also, obviously, things like, hey, I have this 10-page research paper that I want to write, so do it for me. Like, as students, I'm guessing that you have at least seen that before. But the coding aspect is maybe a little new. All right, it's taking a long time. I don't know how long it'll take, so feel free to skip forward a few seconds. There we go. Okay, so cool. It looks like it's doing something. Yeah, nice. And let's see if the preview still works. And yeah, okay, it does. And I don't know, I'm just going to say pizza. And let's see what it says this time. And okay, Domino's Pizza. I don't know if that's like, specifically Millersville. I was hoping to get it to say Hopi, but sure. And if we look at the code, now it is pretty much straight HTML and JavaScript. And so you can see like here's some familiar looking HTML. You got a div, you got a footer, you got a text area, you've got, some JavaScript, and it's code. And yeah, maybe I'll leave it there. I'll talk more about some of the pros and cons of this approach in a different video. But for now, this is just a thing. And it's a big deal because we don't really know the answer to some of these questions. Okay. So how has this affected the industry? And I mean this really broadly. And you can think about your own industry, but it's all kind of related. And so this chart is not a real chart, I'll say. Like, I don't want anyone to take a screenshot of this and be like, Google employee reveals inner secrets of Google. But this chart is very, very roughly the chart of how much money Google search makes over time. And so you can imagine this is like at the beginning of Google search, this is how much they made, and then it really went up significantly and, became the billions and billions of dollar industry that it is now. And at some point in the last few years, it's still making money, but the graph is no longer going up as much as it used to. And any guesses as to why? What is this gray line? This gray line is very roughly when ChatGPT came out. Um, and so folks stopped using Google search and started using ChatGPT. And that might not seem like a big deal, but this has so many repercussions. And maybe I shouldn't oversimplify this much, but I don't think it's that much of a stretch to say that when the world saw that AI, this new AI tool, ChatGPT, which no one had heard of before, was actually causing Google to make less money, Google being this like household name, the entire world panicked, or at least the financial world panicked, because if they take down Google, like what does that mean? And this is when a lot of the tech companies started doing layoffs. So this is roughly 2003 or so. A lot of the big tech companies, which up until that point had been like infinite money machines, a lot of them started doing layoffs. And a lot of investors stopped investing in the companies that they were investing in and started investing in AI companies. And this is not just limited to computer science. This is affecting hiring across the board. Maybe I don't have to tell you, but like the the economy, the hiring sort of culture is very different than it was even 4 years ago. And I don't want to blame AI, but it's all kind of related. And so I think having this background of the history and how it works, I think it's important. um okay, so I won't maybe go into like all the effects on big tech. I'll just say that my personal observation have been that it has shifted the incentives. So before, a lot of companies, including my own Google, really only incentivized growth. So how many more users can you get? How many more people can you get to click that button? How can you get more people to watch more videos, that kind of thing. um, and in my sort of observation, I think that incentive has shifted, and it's no longer really about growth. It's actually more about AI, like AI for the sake of AI, because everyone is terrified of this graph. So everyone wants to be ChatGPT. Everyone wants to be the thing that is making the graph go up. um, and so a lot of companies are adopting AI for the sake of AI, replacing workers with AI, or at least laying workers off to purchase AI. In theory, there's a race to what's called AGI, or artificial generalized intelligence. And this is, sort of a science fictiony like AI that can do anything a human can. This has also had effects on hiring. So hiring has slowed down significantly. There have been more layoffs, and more restrictions around things like working from home, like I do. A lot of folks are being called back in. And again, I don't want to blame AI for all of it, but it is all related under this bigger umbrella of capitalism and stuff. Um, anyway, so as students, I think that y'all actually have a better perspective on this than most people do. Um, and I don't know. I wish we were sort of in person, or at least in a Zoom call, and I could ask you like, what do you think the effects on education have been? Um, I see it as a double-edged sword, maybe. I do think that there are uses for AI. I also think that the incentive systems that students are sent through, specifically grades, I think that that is a bad mix with AI tools. So you have, your 5 classes, you have 5 assignments, they're all due this week, and ChatGPT, or Gemini, whatever AI tool, gives you a button that says make one of those assignments go away. And I don't blame people for using that button, but it does sort of shortcut the learning process. And maybe I'll talk more about this in the next video, but the I don't know, where I get kind of depressed is it's actually not as simple as that. It's not as simple as like I don't know. It's tempting to say like students are using AI to cheat, and I don't think that's quite true. I think that even folks who like want to learn, um, it's tricky because using a tool like ChatGPT or Gemini or whatever, it actually feels like learning. If I can type in a thing and I get a response and I kind of squint at the thing and I mostly understand it, that's going to feel like I just learned that thing. Um, and so maybe I hand that in and I don't feel guilty about that at all. But the problem is that real learning kind of requires being frustrated. It requires like staring at the problem and trying something and not it doesn't work and thinking about a different thing and eventually figuring it out, and like that's how you form the wrinkles in your brain. And what these tools give you is a button that says I don't want to do that, I just want the answer. And again, I don't judge that. If I was a student I would be doing the exact same thing. Um, but I don't know what that means. Honestly, I don't know what that means for education. I don't know what it means for students, and I don't know what it means for teachers. Um, and so I don't know. If you have thoughts, I would truly, honestly love to hear them because I don't know. I'm not a student, so I'd love to hear from you. Anyway, I just have a couple more slides. So um, I will also just say like this could be its own full hour-long talk. A lot of these tools, or every one of these tools, really come with really big ethical questions. So I mentioned earlier training these models, and so it's many humans' jobs to look at some of the worst things on the internet and flag that as bad. And maybe shouldn't give any specific examples, but like, I don't know, think of the internet, think of the worst people on the internet. Not just, annoying racist ants or whatever, but like truly the worst people on the internet. And the output, the images, the videos that they might generate. And it's someone's job to look at that and say, bad, ChatGPT, don't show this. And that kind of job takes a toll. And it's kind of hidden labor that we don't really talk about, that most people don't even know exists. And a lot of the times, this is done by sort of exploited labor. So there's this scandal where um, ChatGPT, the trainers for that were a bunch of workers in Kenya being paid less than $2 an hour to look at some of the worst stuff on the internet. So that's just one example, but many others. So the environmental impacts, this stuff takes a ton of electricity, generates a ton of heat, biases. So um, my weird gendered example earlier, that was based on the training data that it was given, and the fact that it was gendered reveals that it's propagating this bias. And so you get things like encoded racism, for example, or um, if you have an AI whose job it is to screen resumes, what kinds of names does it screen on? And who's responsible for that? Obviously, hallucination, where um, sometimes the math of the words doesn't really make sense and you get the wrong words, you get misinformation, you get the wrong kind of thing. This is why like Google search will tell you to, I don't know, eat rocks and glue and stuff. There's also like generating videos, deep fakes, and all the horrors that come with that. A lot of questions around copyright. So I put all of my material from this class out on the internet for free. The only thing I ask is anyone who uses it, please just give a little link in the bottom back to my website. And my website is in the training data for these tools. These tools will not ever give credit because that's not how they work. And is that okay? I don't know. It's a question. This gets at workers' rights. So if your employer replaces you with AI, is that okay? What rights do you have? I don't know. These are questions that that just society and culture are asking right now. And this is maybe gets a little bit too much into my own nonsense, but like I feel like these tools often represent a consolidation of power. So these tools are from companies that already have billions of dollars, and do we really need one more tool that some big company is charging a monthly subscription fee for? I don't know. I'm not saying one way or the other. I truly don't know where I land. Um, but I think what I will leave you with in this video is I encourage you to ask yourself those questions, and form your own opinions. Since you are about to enter the industry and the industry is obsessed with AI right now, consider tinkering with it. Spend a weekend building a little project with it. I'm not saying you should or like have to, but it might be a good thing for your resume. Um, and just think about how AI will affect your industry, whatever that is. And at the current rate, I don't think there's a way to like completely get away from it, even if you don't personally use it. Maybe your job is like starting to in add it to certain workflows, or whatever it is. And so just think about how will that affect your industry, and how do you feel about that? All right, I think that's basically my last slide. It is. So I'll end it there. I'll do a separate video on some of the interesting observations I've had with using these things to actually do web development. But for now, this will be the talk. So thanks for watching, and I'll see you in the next one.